So we're here in the editor, and I'm going to open the enemy Blackboard. And for the stun mechanic, we're going to want a key of type Boolean that we can use to store the information pertaining to whether or not the enemy is stunned. So click New Key and add a bool key, and this bool is going to be called stunned. Go ahead and click Save. Now we need to set this whenever the stunned Boolean changes on the enemy class. So let's go ahead and go into our enemy class here. Now here in bullet hit is where we set this stunned variable to true. But whenever we set this stunned variable, we also need to set the Blackboard key. So what I'm going to do is create a special setter for our stunned variable. And that way, whenever we call the setter, then we will also set that Blackboard key. Let's make this special setter for the stunned variable. So I'm going to scroll up to the protected section here. And I'm going to create a void function called setStunned with a bool input parameter called stunned. And this is going to be a U function with blueprint callable. Now let's go ahead and create a function body for setStunned. So the first thing we want to do in setStunned is set bStunned equal to the value stunned. And then we want to make sure that we take care of the setting of the Blackboard key. So this means we're going to check to see if our controller is valid. So we're going to say if enemy controller, and then we can get the Blackboard from the enemy. So we're going to say enemy controller get Blackboard component. And from the Blackboard component, we're going to call a function set value as bool. Now this is just like set value as vector or set value as object, only it requires the name of a key that is a bool key type. So we're going to use a text macro, and the name of our key is stunned. Now, in setStunned, we have an input parameter called stunned. So that is the value we're going to use to set our Blackboard key. So let's go ahead and get these input parameters each on their own line here. So now we have a setter that will set our Boolean value, but also it will get our enemy controller, get that Blackboard component, and set the value of the stunned key. This is very important because every time we set stunned, we need to update the Blackboard as well. So now we're going to call this instead of just setting stunned. So let's go ahead and go back to our bullet hit function. So it's going to be bullet hit implementation, and down at the bottom here, when we play the hit montage, we're setting bStunned to true. Instead, we're now going to use setStunned. And setStunned will simply take the value true here. Now that takes care of the C++ side, so I'm going to compile that. And in the meantime, we're going to take care of the animation notify. So let's go back into the animation blueprint. So we're going to go to enemies and grux animBP. And here's the notify. And here we're setting stunned to false, but instead we can drag off of as animBP and call setStunned. Now we have this blueprint callable function setStunned, and we can use the value of false by leaving the stunned input unchecked. And now this will result in setting that Blackboard key. So let's go ahead and compile and save this and open our enemy Blackboard and dock this down here. And that way we can play test this. So I'm going to go ahead and hit play. And I'm going to go ahead and shoot the enemy. And as soon as we get a true value, we should see that in the stunned Blackboard key. Now remember, we have a 50% chance here, so not every single bullet hit is going to set it to true. There it goes, and it went back to false. So sometimes we get it, sometimes we don't, and that's because we have a chance of 50%. So now we have a Blackboard key called stunned, and this we can use in our behavior tree. So how are we going to use our stunned Boolean? In order to prevent a node or branch of nodes from executing, we need to make use of a special behavior tree node called a decorator. A decorator is a special type of behavior tree node that gets attached to other nodes. So take a look at this sequence node here directly under the root. It has a decorator node attached to it. A decorator node behaves like a conditional. It's like an if check that says if a particular condition is true, then allow the node to execute. Otherwise, prevent the node from executing. So a decorator determines whether or not a node can execute. We're going to use a decorator with our bool key called stunned. Now, in order to prevent our move to from continuing to work, we're going to add a decorator to our move to task. So right-click and add decorator. Now, there's a bunch of different decorators that are pre-made and have their own different functionality, but we're going to use Blackboard, and we'll get a new decorator on this node that says Blackboard-based condition. Now take a look at the details panel. We have several properties here. The first of which I want to point out is the node name. We're going to rename this and we're going to say is stunned. And now you'll see that the node itself has is stunned for its text. Now, a decorator has a Blackboard section where there's a key query and a Blackboard key. Now the key query has two possible values, is set or is not set. And the Blackboard key is one of the keys that we pick from our Blackboard keys. We're going to select stunned, and now our Blackboard key stunned, which is a bool key, is going to be checked to make sure we're allowed to execute this move to. Now, for key query, if it's set to is set, then if this Blackboard key is set, the move to will execute. Otherwise, it will not. Now, when it comes to bool keys, they're considered set when the bool is true and not set when the bool is false. Now, since we want to move to the target only when stunned is false, we're going to set this to is not set. Now, in flow control, we have notify observer, which we can select on result change or on value change. Now, it's evaluating this condition every so often whenever the behavior tree reaches this node. Now, if we have on result change selected, then whenever we evaluate the condition and the result is different, then we will abort this node. However, we can also select on value change, and this will abort the node regardless of whether or not we have just evaluated the condition or if we're doing something else. So we're going to set this to on value change so that we can abort whenever the stunned key changes to not set. In other words, changes to false. Now, observer aborts has none or self, and we're going to select self. This means this node will abort itself. It will stop executing on value change as long as the Blackboard condition fails. And since our key query is not set, this means that we will abort when the stunned bool key is set. In other words, when it is true. So if we're stunned, move to will no longer work. Now, we can make this easy for us to test by going to enemy BP and finding our stun chance and setting that to 1, so that way every time we shoot the enemy, we will stun the enemy because our stun chance is basically 100%. Now we can also take our aggro sphere and set the sphere radius to something high, something like, say, 1,000, so that way we will aggro the enemy from far away. This will make testing easier. Now, we're going to need to move our player start back a bit, so that way we start outside of the sphere now that the sphere is larger. Now, as soon as we hit play, we're going to step into the sphere. The enemy is going to start chasing us because we're going to get to this move to task, and stunned is not going to be set yet. It's going to be false, so is not set will pass this condition and move to will happen. Now, as soon as we shoot the enemy and stunned becomes true, then the key query is not set will fail and we will abort the move to task. So let's go ahead and try this out. So I'm going to step into the aggro sphere and shoot the enemy while it's running towards me and see if it stops running. And there it goes. we are effectively stunning the enemy, and that's causing the enemy to stop running. Now we're about to hit the edge of the nav mesh bounds volume, and that's why the enemy cannot chase us past that point. But now we're seeing that stunned mechanics are working because we have this decorator that's checking to see if we're stunned or not. Excellent. So that's going to conclude this video. We now have stunned mechanics, and we have the ability to abort a task in the behavior tree based on whether or not a Blackboard key is set. And we found that if the Blackboard key is a bool key, then true means it's set and false means it's not set. Okay, I'll see you in the next video.